Hello, today I'm going to discuss how to measure the distance or size of an object from a photograph, and I'll be using an Android smartphone and some associated apps. You could apply the same principles to other mobile phones or just to photographs on your computer. First thing you need to do is to calibrate your camera and determine a constant which is particular to it. You need to find an object of a known size. For this I used an A4 sheet of paper, and you need to observe it from a known distance. There are two potential methods you can use. You can use a GPS for this. You would first of all waymark the position of the object that you're observing, and then you would retreat from it, and you would look at the distance estimate so your GPS makes it from your current location to the object. But there is an associated error of both your position and the object's position of, say, plus or minus 10 meters is a fairly typical kind of range. So you would want to make sure that the distance between you and the object that you're observing is much larger than this, say 200 meters or something. There's another method you could use, which would be to use Google Earth and place your object at one landmark and yourself at another landmark. Just two landmarks that are easily visible from Google Earth, and then use the map measure tool in Google Earth. And I use this for very magnified images. I tend to use this for digiscoped photographs of wild animals. Now the equation I use for finding the constant is this one. C, your constant, is equal to the size in centimeters times by the magnification divided by the number of pixels times by the distance between your observer and object in meters. There's no trigonometry here, but don't worry about that, because for small angles, which are typical for this kind of work, you don't need any trigonometry. You'll still get a good estimate. But I would suggest that you make repeated measurements so that you get an accurate constant for this. The two apps that I use for this, Equreka and Pixel Ruler, are both free, and on my phone I can add them to the toolbox for easy access. Equreka is a very handy tool. It provides a template into which you can input data to perform calculations in a simple way, and it will guide you through it. You can add your own equations to this, and you can favourite them, which is exactly what I've done. A live image and examined images may be different number of pixels. This would mean that you would potentially need different constants depending on how you're looking at your image. For my phone, a live image and say a screenshot of a video are actually completely the same scale, so it's great. I only need the one constant here. The equation for my phone gave me a constant of 0.19. I can use that in this equation. Distance equals size times magnification divided by the number of pixels times by my constant. Now, one thing to mention is that the size that you're using here is a known size. So, for instance, if I looked in my field guide, I might find that a certain bird is 21 centimeters long, and then I would go and measure this in my picture in terms of the number of pixels. Now, it could be that these dimensions are actually quite different. A field guide dimension might be for a bird which is dead and is being stretched out on a ruler, whereas the dimension that you are measuring in your picture might be from a live bird which is holding its beak at a particular angle, its tail at a particular angle, is not on a flat. So those dimensions could be a bit different, and it might cause some inaccuracy. But for some measurements, say the wingspan of a bird, which keeps its wings comparatively flat, you shouldn't expect too much difference between these dimensions. Another useful equation is for finding size at a known distance, Now I tend to use this for landmarks that I can find on Google Earth, and it enables me to estimate heights of things like trees and pylons, and that can be useful if you're doing certain types of bird survey field work and want to know roughly how high a bird is flying. You see it fly halfway up a pylon at some distance, you'll be able to give an estimate of its height from that. Now I suggest that you pause this slide and copy the equations if you want to use them, because the following explication showing how I use these apps doesn't show at a particularly good resolution, and some of the writing will be a bit blurred. So here goes. Here's an example with a deer. I open up Pixel Ruler from my toolbox, I move the handles, pick a height of 257 pixels. I then go in and open up Equreka Pro, and I select the top equation. First of all, accidentally unfavoriting it, refavoriting it there. Opening it up, putting in my magnification 25 times, pixels 257. I actually moved the handles inadvertently there, which is why it says a different thing at the top of the screen. Putting my node and distance, the height 110 centimeters. I get 56 meters as my distance.